Welcome to this lesson on the basic rules of differentiation. Whether you're new to calculus or just need a refresher, we are here to make differentiation simple and clear. Let's dive right in. Differentiation is a fundamental concept in calculus that helps us understand how functions change. In simple terms, the derivative of a function gives us the rate at which the function's value changes as its input changes. It's like finding the slope of the function at any point. Let's start with the power rule. It's one of the most commonly used differentiation rules. The power rule states that if you have a function of the form f of x is equal to x raised to the power of n, where n is the constant, the derivative is given by f prime of x is equal to n multiplied by x raised to the power of n minus 1. So if you differentiate x raised to the power of n, you get n multiplied by x raised to the power of n minus 1. For example, if you have the function x cubed, then the derivative of this function is equal to 3 multiplied by x raised to the power of 3 minus 1, which is equal to 3x squared. Let's apply this for the function x raised to the power of 4. The derivative would be f prime of x is equal to 4 multiplied by x raised to the power of 4 minus 1, which is equal to 4x cubed. Next up is the constant rule. This rule is straightforward. The derivative of a constant is always 0. For instance, if the function is equal to 7, then f prime of x is equal to 0. This makes sense because a constant function doesn't change, so its rate of change is 0. Now, let's talk about the constant multiple rule. If you have a function f of x is equal to c multiplied by g of x, where c is a constant, then the derivative is f prime of x is equal to c multiplied by the derivative of g of x. Simply put, you can take the constant out in front and then differentiate the function g of x. For example, if f of x is equal to 5x squared, then f prime of x is equal to 5 multiplied by 2x raised to the power of 2 minus 1, which is equal to 5 times 2x, giving the result of 10x. The sum rule is quite handy. If you have a function that is the sum of two functions, say f of x is equal to g of x plus h of x, then the derivative is simply the sum of the derivatives of these functions. Therefore, f prime of x is equal to g prime of x plus h prime of x, or the sum of the derivatives of g of x and h of x. So, if f of x is equal to x squared plus 3x, then f prime of x is equal to 2x raised to the power of 2 minus 1 plus 3x raised to the power of 1 minus 1, which is equal to 2x raised to the power of 1 plus 3x raised to the power of 0. And when x is raised to the power of 0, it is always equal 1. Therefore, the final result is 2x plus 3. The difference rule is similar to the sum rule, but for subtraction. If f of x is equal to g of x minus h of x, then the derivative is f prime of x is equal to g prime of x minus h prime of x, or the difference of the derivatives of the functions g of x and h of x. For example, if f of x is equal to x cubed minus x, then f prime of x is equal to 3x raised to the power of 3 minus 1 minus x raised to the power of 1 minus 1, which is equal to 3x squared minus x raised to 0. Since x raised to 0 is equal to 1, the final result is 3x squared minus 1. The product rule comes into play when you need to differentiate a product of two functions. If f of x is equal to g of x multiplied by h of x, then f prime of x is equal to the derivative of g of x multiplied by h of x plus g of x multiplied by the derivative of h of x. This means that you take the derivative of the first function and multiply it by the second function. Then add the product of the first function and the derivative of the second. For example, if f of x is equal to x squared multiplied by sine x, then f prime of x is equal to 2x multiplied by sine x plus x squared multiplied by cosine of x, since the derivative of sine x is equal to cosine x. Then, factoring out the common factor x, we get x multiplied by the quantity 2 sine x plus x cosine x. Finally, let's cover the quotient rule. If you have a function that is a quotient of two functions, f of x is equal to g of x divided by h of x, the derivative is f prime of x is equal to the derivative of g of x multiplied by h of x minus g of x multiplied by the derivative of h of x all over the square of h of x. In other words, you differentiate the numerator and multiply it by the denominator. Subtract the product of the numerator and the derivative of the denominator, and then divide everything by the square of the denominator. For example, if f of x is equal to x squared divided by x plus 1, to get the derivative of f of x, we take the derivative of the numerator x squared, which is equal to 2x, multiplied by the denominator minus the numerator x squared, multiplied by the derivative of the denominator x plus 1. Applying the sum rule, the derivative of x is equal to 1, and the derivative of 1, which is a constant, is equal to 0, which gives us 1 as the derivative of x plus 1. All of this is divided by the square of the denominator x plus 1. Then f prime of x is equal to 2x multiplied by x plus 1 minus x squared multiplied by 1, all over the square of x plus 1. This equals to 2x squared plus 2x minus x squared, all over the square of x plus 1. Then, simplifying this expression gives us 2x squared minus x squared is equal to x squared, then plus 2x remains, all over the square of x plus 1. Factoring out the common factor x in the numerator further gives us x multiplied by the quantity x plus 2 all over the square of x plus 1, which is our final answer. To recap, here are the basic differentiation rules we covered. The power rule. Constant rule. Constant multiple rule. Sum rule. Difference rule. Product rule. And quotient rule. Now, practice makes perfect. Try out these problems to reinforce what you've learned. Differentiate f of x is equal to 3x squared multiplied by x plus 1. And f of x is equal to sine x divided by x squared. The answers will be flashed on the screen after the countdown. Here are the answers. Great job today! Differentiation can be challenging, but with practice, it will become second nature. Keep working through problems and don't hesitate to revisit these rules whenever you need a refresher. Thanks for watching. Happy learning!